Welcome back to another video in this series. Last video, we went over host-related indicators of compromise. In this video, we're going to go over a digital forensic technique. So we'll actually start with using Tcpdump, right? So it's a tool that can be used for packet analysis, right? And we can actually capture packets with this tool that traverse through a network. So after capturing the packets, we can actually investigate them and analyze them. And it not only can be used for packet analysis, but also for troubleshooting various network issues. And so I'm just going to use it in a few steps here. I'll do a little checking of the status with different commands as far as how well we can use Tcpdump. So I'm just going to start off with this first command here. It'll type for me. Let's see. Perfect. And this is just used for specifying the interface, right? And it'll actually listen continuously until I tell it to stop with the code. Until I press the button Control and C at the same time here. Let's see, there it is. Cause I didn't let it run long, but so it shows 0 packets captured, received, or dropped, right? So I'm actually going to clear this out. I'm going to run another command here. Just going to run the command a specific number of times and I'm going to demonstrate how to do this. So instead of it running continuously, and actually, there it is. All right, so as you can see, this is the count, right? At least I'm specifying the count that I want, which is at 10. And then it'll eventually phase out and complete the captures for the package for the specified number of times, right? So let's see. Should be done here in a moment. Okay, I guess not. That's fine. But nonetheless, that would be the command you would use for a specified number of times. You can do it 10, 20, however way suits your needs, right? So now I'm just going to list the available interfaces, right, in our system with Tcpdump. So I'm going to enter in this command here, right? So we have etho, lo, ne, nflog, nfq, as far as the different interfaces that we have, at least available interfaces, right? I'm going to clear this out again. I'm just going to save the output of the Tcpdump command in a file with the pcap extension. So I'm going to run it like this. Interface etho. All right, perfect. So now I'm going to let the command run for a few minutes. So we can actually see if we can capture a few things. It's going to run continuously because I didn't, as you can see, specify the amount of times it's going to continuously listen until I tell it to stop. So again, for a couple minutes, and then I'll see what we capture. All right, so it's been a couple minutes. I'm going to stop it here to see what we captured. All right, so 1 packet received by filter, 1 packet captured for that packet to be received. So that's fine. So now that I sent the output to a file, I'm going to read it with the -r parameter. Now to do that, I'm going to type in, read the file, and of course it's pcap. Yeah, there we go, reading. All right, so we see the IP, the net BIOS, things of that nature, right? All of that jazz. So we see the output from the files that's displayed on the screen. So I'm just going to clear this out now that we've gotten that information. So rather than type a specific interface, right, I'm going to just capture packages and all the available interfaces to me. So I'm going to do, if I can spell it right. All right, so I'm going to let it run for a few minutes, but also while I'm letting it run, it's going to run continuously until I tell it to stop. I'm actually going to, actually, you know what? Let me have it stopped, and then that's fine. Then I'm just going to clear this out. So by default, Tcpdump captures all the types of packets, right? So we can actually limit it to capture only a specific type of protocol package. So So I'm actually going to do that instead. Let's see. All right, so I'm going to let that run actually for a few minutes. Then I'm going to open a new terminal, Windows, and see, ping. All right, and then we're going to see it simultaneously. Once this starts pinging that IP, then it's going to start simultaneously. You're going to see the capturing here that we're listening for. All right. Perfect. And it just keeps going and going. And then I'll just, now it's been a few, more than a few things. I'll just stop it here. And I'll also stop this one as well. So these commands are, the, no, this one. So these commands are captured by Tcpdump, right? So, so we see everything that's been logged as far as when it was pinging in the other terminal windows. So now we're going to move on to being able to capture packets with Wireshark, particularly instead of Tcpdump. Wireshark it's an alternative tool. It can be useful when conducting passive like reconnaissance, right? As it doesn't interact with devices directly, but it just samples moving them on the network, right? So it could be done by capturing traffic and packet logs to then review them. So let's actually swivel over to this server here. All right, so everything is loaded for this server. Again, we're going to capture some traffic information using Wireshark. And the major difference is Tcpdump and Wireshark. Tcpdump just capture things in real time on the CLI based kind of way, and Wireshark is more user friendly as far as some sort of GUI that comes with doing essentially the same thing, right? And Wireshark is also a free open source tool for like passive reconnaissance, right? That can be used to analyze network traffic, right? So it's typically referred to just a network analyzer, right? But nonetheless, let's move forward. So let's actually close this out and close it out. Let's open up what we came here for. There we go. Actually, you know what? Let me close this back. There we go. That's better. Remind me later, so that's fine. All right. Capture, Ethernet. Actually, take a look in here. Let me open this up a bit. All right, so now we see that the packet capturing process has started, right? So I'll just leave it running for a few just to collect some, at least a little bit of information flowing across the network devices, right? So while it's running, I'm going to actually swivel over to this server. Let's see, this one here. Oh, okay. Actually, you know what? I'll just reboot this one. I thought the one I needed to swivel to, but I'll actually need to reboot this one here. All right. So take a step back for a second. So what I did was, while I was intentionally launching Wireshark with this particular server, I meant to, instead of rebooting this one, to reboot this one to showcase a few things in Wireshark. As we can see, we observed the package here. While the practice lab for Windows reboots, right, we'll see ARP data as well as TCP traffic, right, the TCP here, right? But we want to look for the ARP request, right, when it starts, which it just did. And bear in mind the IP for this device is listed in a diagram, right? And we'll need to look for the address, which is the 192.168.0.1, and it also told it to sell 0.2. That's nice. So once the device has rebooted, now we can actually end the packet capture, which it looks like it's fully on right now. Well, like it's supposed to be there. Okay. All right, perfect. So I'm actually going to end this packet capture or the capture process, whatever you'd like to call it, here. then, all right, perfect. So it's officially ended. So let's take a look at ARP on the share broadcast here. Okay, reply, request. All right, so we have several ARP packets that were captured by Wireshark. So just going to click here to move this filter. This is okay. So now we're going to analyze the captured information, right? So we can actually list information according to like different tabs and then move it to basic filtering techniques, right? So the knowledge of protocols is essential to understanding all the information in Wireshark. So I want to explore a few of the details as far as the traffic flows and how to understand them using the main interface. So let's explore what we have here. So let's see. All right. So this guy here, or this category, right, or the number, right? This is the packet number for which is counted for each packet that's recorded, right? And then the time is the time of the packet recording, right? And then the source, it is the source IP address. Then we have the destination, which is the destination IP address. And we have the protocol, which is the type of packet that has been used, ICMP, ARP browser, DHCP, dynamic host, things of that nature. And we have the length, as far as the length of the packet, of course, 42, 54 bytes, whatever it might be, 54. And we have the info, right? Particularly any extra information which could be useful to that particular packet, right? So actually, let me click here. First ARP, and that's going to be at the top, right? So now you notice pretty much just like with any dialog box that has different, submenus, you're able to not categorize, but, have them go in alphabetical order for each submenu. So for destination, place that in a alphabetical order. Also, the same thing for protocol makes it a bit easier to have them sorted out based on their names, right? So just going to scroll through a few of these as far as finding out the ARP results from those sessions, right? So just need to pretty much all the communicating devices that's calling out to check each other IP addresses. And we'll see that all the addresses listed for all the switch devices are connected to the same Ethernet adapter, ultimately, right? So we can see the calls for 192.168.168.0.1 to 0.2, which is the pretty much this server as per information about the DCO1 server. So we could also see devices establishing their address. So the device, which is 0.2, which is for this server, it confirms its address location at here, right? 15.5D EA73, 492316. I know what I was reading for a second. But yeah, so there's quite a few things that we can see through capturing just a few packets, because we didn't really have it go for that long, right? So its frame really can be seen making a gratuitous request, right, via a broadcast. Actually, we could see that. Where is it? See here. That's not. See. All right, but yeah, so effectively it's setting a source and destination and address information against IP. So if another machine did own 0.4, the Windows server would dictate or detect a duplicate IP address and then promptly change the user to change the configuration. So Wireshark is just decode the OUI, and then we can take a look at the MAC fields, right? To also decode the multicast and broadcast bit and the locally administered bit. So yeah, so let's actually take a look at the DNS filter, another capture here. So, all right, so we see a standard query response for practice labs and pad practice labs or WPAD practice labs, right? This query is going out, right, for DNS protocol. I'm actually going to remove this filter here. Then I'm going to move down so we can see plenty of, let's see, I should have just, so we can see pretty much a large portion of this is the TCP protocol, right? So there's a lot of traffic from all the devices that are using that protocol. So there's a lot of information on that TCP that's really flowing in. Can it kind of be overwhelming to inspect? So let's actually take a look at a filter that we can use to make it a little bit less daunting. All right, perfect. All right, so now we can view all the traffic which has flowed, particularly from DC01, that particular server, since Wireshark has begun recording, right, those packets that were being delivered, right? So to make things a little bit less daunting. And I'm just going to exit out here. Now we're going to just display the capture information with Wireshark. So now we can explore different methods, right, of output to view the data in a more appealing and instantly rewarding format, other than Tcpdump. Just the numbers on the screen, and kind of get a user more comfortable with using something like with a pretty decent GUI, right? So by viewing the key information more rapidly, we can discern if a more detailed investigation is required or not. So I'm actually going to stay on this server. So I'm just going to make sure that the filter has been cleared of content. So we're back at the original capture information. So I'm just going to click here. See, there it is. All right, perfect. So hosts usually have their addresses resolved from an IP to the names, so they'll be listed in the initial section. So we can identify the Windows server and the DC01 server from this list, so the information can be confirmed in the topology. So you see here, host TCP capture file. Okay. The protocol hierarchy. Wow, quite a bit. At least for a lab. All right, so the output now here, it just shows us the details in terms of the packet types, right? And how much information flowed in each protocol type, right? So for example, if we were interested in TCP packets only, then we can select that from the list, right? Which is usually noted as IPv4, right? So actually, let's take a look at it. All right. So we can see that here. Percentage of packets, which is pretty much nearly all of them that were on this protocol. So just going to close that out. I'll close this out rather. Now we're back on the main screen, right? So now we can see the IP protocol, IP being applied as a filter, right? And here, which you can see that here. Okay. All right, so so this is going to inform Wireshark display those packets in the capture window here, right? So so now we're looking at only HTTP traffic, right? So we'll notice that the filter also has a syntax for HTTP. So to discover really any devices communicating directly, we can clear this filter again. Let's just filter it. Wow, it's been acting kind of weird. Yep, see. I don't know. So we can actually, let's see, take a look at the conversations here. TCP. Okay. Yeah, this looks like about right. All right, so let's see. All right, perfect. So just making sure that I was on the right tab. But naturally I would be right, because TCP were most of the protocols that were used as far as everything that was captured. So it's important to understand that even though a person's not directly using a device, it's always having conversations on the network, right? Trying to communicate out, unless very specifically programmed not to, right? So you can see the different packets, right? A to B, B to A, and vice versa, and blah, blah, blah. A lot of conversation there. So finally, we'll look at some graphical information we can capture. So we can actually, let's see, take a look at the graph, and we'll see different spikes there, right? So the graph in the image just shows all the packets, right, as a line graph in the TCP errors, as a bar graph seen in the same diagram. So we're going to actually leave just the all packet there, right, for the graph. So there is a minor change, of course, in the graph output, just because there are either no or very few TCP errors. And it's going to close this out. So now we're going to view packet capture logs. So we can actually use Wireshark to save captures to the document folder with continuing, before we continue with the analysis, should any mistakes be made during the capture, so we can actually reload the file and pick it back up again. So to view this, we can actually say here and the file, save as, and Wireshark, Wireshark by default, it saves as you can see here, the PCAP in G. However, we do need to change this file type for other programs like Tcpdump to view the content. So for the save as type, let's see, the list of types here that can be considered for saving a file, really. Yeah, I'll just do this one. File name. That'll work. And document, yeah, that's fine. All right, perfect. So we're good to go there. And now we can move on to our next exercise, which is the using OS forensics, right? So typically when you use Windows to delete a file to remove from a disk, right? When deleted in Windows, the OS renames the file and moves it to the recycle bin, right? So when we delete it, when we delete the file in Windows or Windows Explorer, we can actually restore it from the recycle bin. So, okay, so another method is using the MS-DOS method or command, right? So this method simply doesn't move the file to another recycle bin instead of removing from the master file table listing. So right now, what we're going to do is collect user SID. So within the Windows OS, let's see, user and group account are identified with a string called a security identifier. So let's take a look at these here. All right, perfect. And now we're just going to type in this here. Actually, yeah, there it is. Fairly quick. All right, so now just retrieving the administrator's SID, right? So now the SID of the administrator is displayed, right? So we can observe that as far as the return SID. Now we're just going to take a look at some deleted files. So there are several ways to view deleted files in Windows, of course. What we're going to do is we're going to delete some files and view them using a computer forensic tools like OS forensics. So to view deleted files, let's see next here. And let's open this up. And then take a look here. Let's see, what can we download? Actually, first, let me open this up before I download anything, actually. Yes. So this is good. This is good. Put it on the desktop. We're going to install it. Install may take a couple moments to complete. All right. So the install has finally completed. So let's hit finish here. Fine. Continue using the file version. Right. And then let's get to see. Make sure I'm on the right thing here. Actually, you know what? Let me go back here. My perfect. Yeah, I was gonna a bit. I'll throw it off there for a second. All right, so deleted files. Then do this here. All right, perfect. So now we're just going to add the. All right, perfect. So just want to make sure. All right, was that the C drive, which is our local drive? This drive, that's fine. So then check that. All right, perfect. So we're good there. So now we're just going to hit start. Then file. There it is. All right, so let's expand this. All right, perfect. Go down. Let's expand the recycle bin. All right. Then let's see. It's 152. Hmm. Um, Actually, let me see. Where's the? So I'm looking for the value. There it is. All right. So the administrator. So let's see. 3667813. Yeah, let me open this up a bit better. Three. Oh, these are exactly identical. Let me open this up some more. 600. 311. Okay, 500. Right. All right, perfect. All right, so let's actually minimize that just that. So it only contains one hidden file. Actually, let me open it back up that one. Right. So it contains one hidden file, right, that we see here at the desktop, INI. So just going to keep the this browser window open while I get back here, right? And then let's open this up. Just try not to go too fast. If I go too fast, then it'll I could miss something, right? So let's right click here. Actually delete. All right, perfect. And now the anonymous folder is no longer there. So let's close out this browser or this window rather. So now I'm back on the file system browser, right? So I'm just going to right click here. Let's see, then refresh. Is it refreshing? Do it again. There it is. I was refreshing the wrong portion. All right, so now we see the two additional folders, right? So the folder called Anonymous that I just deleted, it was actually renamed. But the window changes the file name with a unique identity on the recycle bin, right? So it was changed ultimately, right? So a new file was added, so which of these definitely resembles the folder that I had just deleted. So just actually, let's see a few other details here. Date created, date access. modified date, the size, the attributes, total stream size, all of that jazz. It gives us quite a bit of details about the deleted file, right? So let's actually click on deleted folder. Go here. All right, perfect. So now we see more details about the deleted files, right? So we can examine the different properties about the deleted files, right? That are displayed in each column header just by scrolling, right? Then actually, let me click this and let's look at the properties. All right, so now we see the location, right? Where the dialog box shows us the location. It just shows information about the deleted file that's presented, right? So we can actually observe the different properties of this document file, right? From the file info, text viewer, hex string, file viewer, metadata, things of that nature. We could go on and on, right? So let's actually take a look at file viewer. So it shows the message unsupported file format, right? And that's because it's not able to read the file content. So we click on the hex string viewer, right? And it'll have the hex and the AS. Let's see. Actually open it up a bit more. All right, perfect. So we see here we have the X and the ASCII patterns that are displayed. So we notice there's certain tags like body, let's see, body here, and then we also see head as far as mentioned, right? So actually we're going to click extract to get information about the data that we're seeing, right? So now we see the extracted data content from the file, right? So let's take a look at the text viewer. So the text viewer tab just displays text and other formatting codes, right? Pretty much. And the metadata just displays. Now I can't talk. I can't talk. I can't spell. So the metadata tab just displays only one property, right? The title, one property of the file. So I'm done looking at the details. So I'm just going to exit out of here, and we still have that selected. So now we're going to view the location of this file on the disk, right? So disk offset. So now we're just going to the raw disk viewer. Yep, there it is. It jumped directly to the disk sectors, which are highlighted in green, where the file one file.html is located in disk. So we can scroll down, actually see the clusters that are marked free, right? So just raw data, raw disk viewer, right? So we can see the associated clusters that are designed as free. So it's marked as available for new data. So it's not actually practical to scroll through the disk map to search for something that may be of interest, as this will take some considerable time. So you can actually hit search if you want to search for something in particular. Then actually I'm going to type in head, similar to another video I did before, right? And then actually, my fault. There it is. All right, perfect. So now it's looking for everywhere where head is mentioned, it'll populate here. And then it just show you the pattern where everything is found, right? Then the sector, the partition, the files, object type, things of that nature. So it just indicates the byte offset, the content, right? The file encoding, the drive, right? And some other information. So I just wanted to showcase that, right? And I'm also going to close this out as well. Yes, I do. Okay, perfect. So now we're back on the desktop, and that is the end of the video. So we just went over a few of, not a whole lot, but a few digital forensic techniques, right? So just a brief recap of our video, we used Tcpdump to take a look at a few things as far as network analyzing. We captured packets with Wireshark, which essentially the difference between the two is just the GUI interface that Wireshark uses, make it a slightly more friendly more friendly user, more user friendly to be able to use it with a GUI like Wireshark. And then we also used OSForensics as well to take a look at the contents and details of deleted files as well. So in the next video, we'll actually be going over certificate management, and I'll see you there.